morning everyone. In this video I will continue my discussion with implementation modeling steps. Okay, I'll be specifically focusing at testing. So if we have carefully modeled the application, we will really reduce the errors in the software. Okay, and that means like it needs lesser testing as well. We have discussed wide range of guidelines. Okay, so if we follow all the things properly, okay, and if we carefully design an application, and if we carefully model the application, okay, including the analysis and design, okay, we will reduce the errors in the software. But testing is still very important actually. So testing is the quality assurance mechanism for catching these residual errors, whatever the errors like which you have forgotten, so which were somehow or other like slipping. Okay. Testing also provides an independent measure of the quality of your software. Okay, so the number of bugs actually found for a given testing effort actually is an indicator of the software quality. Okay, with time, like this number should actually reduce. Okay, so with experience also like this should also reduce. Okay. So testing is in that sense like very important. It is also a independent measure for the quality of the software. So we have to keep careful records of the bugs that we found, okay, as well as all the customer complaints whatever we receive. Okay, so all these things like we should be carefully recording these things, and we should also store them because like in future also you will be extending the software. Okay, so then all the previous testing records should be there for your access. Of course, if the software is sound, the primary difficult for the developers is to find these occasional and odd errors. Even if you get any error, okay, fixing that error would be relatively easier problem. But if the software is haphazard, okay, really bad, okay, so it's not developed in a proper way, okay, so we have not followed all the modeling concepts which we have discussed, okay, it's also very difficult to fix the errors once you find them. Yes, so we should be very careful with that. Testing generally, like you may feel like okay, it is for the implementation, you write the code and then like you test it. It is not the case actually. We need to test at every stage of this object-oriented development, not just the implementation. Say for example, during the analysis, we test the model against user expectations. Okay, so whether the model is actually answering all the questions, okay, what the user's expectations are. So we ask the model different questions and seeing like if the model actually answers them properly or not. We will be regularly checking that. So during that analysis stage, like we did that sort of testing. We should do that sort of testing. During the design stage, like you define the architecture, okay, and you basically estimate the performance and everything. Can you be able to simulate its performance of the system? Okay, so during design stage, like we have to do it with these things. Of course, when you come to the implementation stage, you definitely test the source code. Okay. Looking at different steps of the testing should actually start, okay, from the small pieces, okay, and then like eventually it has to move towards the testing entire application. So basically you will be testing bits and pieces and then like you will be testing the complete system. Okay, so in that sense like developers should begin testing their own code. Okay, when developer is writing the code, so he has to test his own code. That means like the classes, methods, and all the things like whatever he is developing, he has to basically test them, okay, one after the other. This step is actually called unit testing. Okay, so you will define a lot of unit tests for your source code. The next step is about integration testing. So you have tested the individual pieces, okay, how these individual pieces, say for example the classes and methods actually fit together in this bigger application. Okay, and you should be actually doing this integration testing as soon as like you start adding new classes, new methods, and then like you start building the system. So then integration testing should be in successive ways, putting the code together in increasing chunks of scope and behavior. Okay, then the final step in this process is actually the system testing. So you have developed the complete application, so now you are checking for the entire application if there are any bugs in it. So if you do like this one in systematic way, so you can be sure like you can actually clear, you can identify most of the bugs and then like you can actually correct them. So let us look at unit testing. Okay, so developers actually do this unit testing directly on their source code and they actually do it. Okay, they also do the integration testing. Why they actually do is like they understand the actual detailed logic of the development and likely sources of errors also they know it better. Okay, so in that sense, like you are actually involving the developer directly in the beginning of the testing itself through this unit testing. So developers should try to cover like all paths and all cases. Okay, use extreme cases, extreme arguments, special values for arguments. Say for example, if you write a program like where the input can be like 1 to 100, okay, try it 1000. Okay, so of the values, okay, for the arguments. So see like what happens. Okay, if your system can support the scale of only 10 clients, okay, give 20 clients, what will happen? Okay, so that's about you can test these things in the unit test itself. Of course, for doing this one, like you have to instrument the objects and methods. Okay, so instrumenting is actually adding something more, okay, to these sort of objects and methods, okay, for the purpose of gathering some information. So Java has a complete instrumentation API actually for that one. For the people who are interested, you can actually go and check it. So it deals with instrumentation, agents, etc. for checking the performance, etc. Additional information for the people who are actually interested. But in general, like already for this unit testing, you can actually put assertions, something like preconditions. What the method before you actually come to that method? Okay, what should be the preconditions? Okay, and what should be the post conditions you are expecting once you actually executed that method. Say for example, like a method basically changes a certain global variable. Okay, see that precondition is like whether it is a particular value, what happened after the method execution, whether it is properly behaving or not. Post conditions you can check invariants and everything in your code. You are doing all these things to basically trap any errors if there are existing in your source code. That's about unit testing. Then the system testing. Okay, so of course, like unit and integration testing you have done earlier. Okay, so along with the unit test, like you can also have the integration test. But system testing, okay, it is actually a little bit different and also like a little bit more. Of course, like the developer will be doing that. Okay, because like he developed the system, he will actually check whether everything is working properly or not. But usually there will be a separate team. Okay, so these are different from the developers. Okay, who will actually carry this system testing. So this is a natural role for, say, for example, quality assurance organization, okay, QA organization. So these QA, okay, so these people, okay, so this separate team actually should derive their testing from the analysis model itself, okay, from the original requirements, and they should prepare their own test suits in parallel to the development. If they do like that one, then they are not actually influenced by this sort of development process, and they are not distracted by these details of development. Okay, the testers. Since they are completely different from the developers, they will not have any bias. Okay, and then like they can provide you some sort of independent assessment of the application. Okay, and once all the system testing is finished, it is called alpha testing. Once it is complete, okay, customers perform the beta testing. So that means like you will deploy the system at the customer locations, and customers basically do the beta test. Once, okay, so any bugs are identified, okay, you basically correct them. Okay, once everything looks good, then you actually go for the general release of the application. But we have already seen like these QAs actually identify these sort of test cases from the modeling, from the models themselves. Okay, so this is what I said. So if you really look like from where like you can actually get these test cases. Okay, so the scenarios of interaction model which we have discussed. Okay, they actually define system level test cases. They provide you a lot of test cases. You can actually generate additional scenarios from the use cases and also from the state machines. Check for both typical and atypical cases. Typical cases are like how the system should behave, whether it is behaving or not. Okay, and the atypical cases are like we discussed about the error conditions and all the things. Okay, say for example, what happens if something wrong happens? Say for example, what happens if there is a ATM, the person has come and then like he started the transaction in the middle of the transaction, he left it and then like went. Okay, what will happen? So, for example, if your transaction actually needs the card to be put in the ATM, say for example, the person is user is trying to pull the card, what you will do? Whether you will hold the card or whether you basically give him the card and then like end the transaction. Okay. So if the application is designed like that one, even the test cases should also be looking at these atypical cases, extreme cases. Also pay special attention to this sort of performance and trust testing. Okay, the software when you are developing a software for multi-user and distributed access, the way like we have seen in the ATM example. So all of these subcomponents are existing. Subsystems are distributed components. So you need to have distributed access across them. So test all these things. Okay, what happens if certain network fails? Okay, what happens if all of a sudden like there is too much load? Of course, we have during the design like we have actually identified like it will not have much bigger load than the number of ATMs. Okay, so approximately 60 concurrent transactions, isn't it, per second? So that's what we have discussed at that time. So of course, like every system will have its own performance and requirements. Okay, but just test this. Okay. So for doing all these things, like use test suits. So these test suits basically automate the procedures. They will also be helpful for rechecking the code for bug fixes and detecting the errors. Okay, and then like these are also useful for future releases. Okay, future software releases. But then like in your software, if the human intervention is also required, automating the test suite may not be completely possible, but still it will give you enough things. And then like there are some test suits like which actually can automate that human interaction as well. Okay, that's about looking at the complete unit testing. Okay, so and integration testing and system testing. Okay, testing on itself is a pretty huge concept actually. Okay, so I mean like I discussed this in one small video because like we are actually discussing testing as part of the object oriented development process completely. Okay, so I quickly touch the topics. Okay, and if you are interested, so there are additional references I am leaving here. Okay, so for example, if you want to know about Java instrumentation, I left a link here. Want to know more about unit testing, you can even try it in Java. Okay, and recently there is a lot of discussion about continuous integration. So that means like from the day from the beginning itself you will start the development. Okay, start putting the code, you will already start worrying about developing the code, testing, doing all the things, integration. Okay, so for example maintaining its versions and everything, and also the complete deployment at this client infrastructure. So it is called continuous integration. These are all relatively recent concepts. Okay, so you should be checking those things as well. Of course, like with time, like you will be learning these things. But general reference for this video is concerned. With this one, like we have finished chapter 17. Okay, object-oriented modeling and design with UML. Okay, Michael Blaha and James Rombo. Not just that one. With this video, like we have also finished our object-oriented development process as well. So whatever is involved in this curriculum, we have actually completed that part as well. So this is the last video for this course is concerned. Thank you very much for your attention. Okay. Thanks for all the support and thanks for all your feedback. Okay. Thank you.